All right, class, welcome back. We're gonna do types of problems, which are money problems. There's actually two ways to solve these, and I'm gonna show you both ways for both different examples. You can use whichever way you feel comfortable using. I'm just gonna show you both. Before we start this, the one thing I wanna remind you is that when we're doing money problems, we need to take into consideration that they're usually given to us, if they're coins, they're usually given to us in their cent form. So when we have a problem like this where we're asking for $1.08, or sorry, $8.05, what you need to make sure you do is that you change the $8.05 either to 100, so it can become 805, so you have to change it to cents. Or what I like to do is I just like to multiply the like I put the decimal value for the coin. So for a quarter, the decimal value, since it's 25 cents, it's just going to be 0.25. For a dime, it would be 0.10 because they're 10 cents, or for a nickel, it'd be 0.5. So I personally like doing it that way. If you would like to put in 25, just make sure that you change this to a 100 and 805, so that you're changing it to cents and not dollars. Okay, so I like to convert the coins into dollars, but if you would like, you can convert the dollars into cents. Okay, so we're going to do the first question, and it's going to be, Joanne has $8.05 worth of quarters and dimes saved. She has 7 more quarters than she has dimes. And how many of each type of coin does she have? So when I solve problems like this, I usually use the other method, but a method that I found very easy to use at the beginning was something like this. So I'm going to make a chart. So I'm going to say I have my nickels. Or sorry, not my nickels, my dimes. Nickels is the next one. I have my dimes, right? So I have my dimes, and I'm just gonna write that in here. And then I have my quarters. Right? And I'm gonna draw that like that. And then I'm gonna say at the top, I have the number of coins. And then I have the value of each coin. So the number of each coin times the value of each coin will give me the total value over here. Cool. So in this specific question, it says I have $8.05. Let's try that again. I have $8.05 in total value when I add these two together. I know that Joanne has 7 more quarters than she has dimes. So I'm going to say she has an X amount of dimes, and then she has an X plus 7 amount of quarters. I know that the value of each dime is just going to be 0.1. So I'm going to multiply that. I'm going to say it's 0.1 times X. And I know the value of each quarter is going to be 0.2. And I'm just going to multiply it by the amount that I have. So X plus 7. Right? So you can just leave that out of here. You're just going to put the values, and then you're just going to multiply. You have 0.1 times X. Right, because these two are multiplied by each other, so multiply here. You have 0.25 times X plus 7 is going to give me 8.05. Right, so that's my equation. I'm just going to take this total value, and I'm going to add them together. So I'm going to say 0.1x plus 0.25 x plus 7 is equal to 8.05. And that's how I made my equation. Okay? Then what I'm going to do is I'm going to say 0.1x. I'm going to leave that as it is, and I'm going to distribute this in. So I'm going to say 0.25x plus 7 times 0.25. And honestly, if you're using like whole numbers, this part might be a little bit easier, but you have calculators, so you can use it this way. And I'm left with 1.75. equals 8.05. I'm just going to go in and collect my like terms. I'm going to go and collect those. So I have 0.25 plus 0.1, which is going to give me 0.35x. Sorry guys, just need to get rid of that. Plus, I still have that 1.75 left over, equals 8.05. Right? Now what I'm going to do is I'm going to try to get the x by itself. So I'm going to do 0.35 x. I want to get rid of the 1.75 minus 1.75 equals 8.05 minus 1.75, right? So I have 8.05 minus 1.75 equals 6.3 over here. I'm going to get rid of those, and I'm left with 0.35 x. I'm going to divide both sides by 0.35 to get rid of this 0.35 here. So x is equal to 6.3. 0.0 divided by 0.35, so I'm just going to put that in. 6.3 divided by 0.35 is 18, so x is equal to 18. And see how even though I had decimals, I ended up getting a whole number. That's because of just how decimals work, right? So I have x is equal to 18. What did x represent? It represented the number of dimes that I had. So I can say, if I want to find how many quarters I have, I know quarters is x plus 7. So I'm going to do x plus 7 equals my number of quarters. 18 plus 7 is just 25. So 25 equals the number of quarters, right? So I'm going to say, therefore, I, or whoever this person was, Joanne, right? Let's write her real name in. Joanne had 18 dimes and 25 quarters. And that's the answer. Okay, so we're gonna move on. That's one way of doing it. And the other way that I could do this is the way that I usually go about it, because logically it makes the most sense to me. I would honestly recommend using this way. I think it's pretty easy. I might start using it more often, but logically the other way just makes more sense to me. So this says, Jasvinder has $60 worth of nickels and quarters saved. She has 300 coins in her piggy bank. How much of each type of coin does she have? So how I like to write this is I like to write it in different, I try to figure out what everything's saying and then write it in terms of that, right? So it says Jasvinder has $60 worth of nickels and quarters saved. That means she has $60 worth of 0.25x plus 0.05. I'm going to define my nickels and dimes. So let's do that first. So let x represent, and you are more than happy, you can write n equals nickels, q equals quarters, whatever you want to work with. Let x represent nickels. I might do that because it might be easier to read. So let n represent nickels. Let q represent quarters. So I know two things for sure. I know that if you add all her nickels and her quarters together, she has 300 of them physically. I also know that if I add the value, if I do the value of a nickel is 0.05 n, plus the value of a quarter is 0.25 q, similar to what we did at the top, all that together is going to give me $60. So I have these two separate equations. What I can say here now is I can rearrange formula number 1 And I can say n is equal to 300. So if I want to get n by itself, n plus q minus q equals 300 minus q, which is what we learned when we were rearranging our formulas, right? So n is equal to 300 minus q. So another way for me to write n is 300 minus q. Okay? So now I can just substitute this value of n into this equation. So I can say 0.05 times 300 minus q plus 0.25 q, because now everything's in terms of q, is equal to 60. Right? Now I'm going to expand that out. So I'm going to do 0.05 times 300, which is going to give me 15, minus q plus 0.25 q is equal to 60. Right? Now what I can do is I can start collecting my like terms. Oh, sorry, I forgot to distribute this in. So I had 0.05 times 300, which is 15, minus 0.05 q. Right? So now I can just start collecting my like terms. So I have this minus 0.05 q and this positive 0.25 q. So I can just add those together. So I'm going to do negative 0.05 plus 0.25, and that's going to give me 0.2 q. And then I have this, and that's going to be a positive, right? Because negative plus 0.25 is going to give me a positive, because it turns out to be positive too, 0.2. And then I'm going to have plus 15 is equal to 60. Now, if I want to solve for that q, I want to get the q by itself. So I'm going to say 15, and I want to get rid of the 15. So I'm going to minus 15 on this side. Equals 60 minus 15. So I'm left with 45 on this side, and I'm left with 0.2 q on this side, right? And then what I'm going to do is I'm going to get rid of the 0.2. Get rid of it on both sides. So 45 divided by 0.2, q is going to be 225. And I had said sorry everyone, my recording just stopped. And I had said that q, if I just go back here, represented the amount of quarters I had. So therefore, you have 225 quarters. If I wanted to find out how many nickels I had, I just have to go back and plug that into that equation. So I have n is equal to 300 minus q equals 300 minus 225, which will give me 75. So I have 75 nickels and 225 quarters, so I'm just going to write that in. Therefore, I have 225 quarters and 75 nickels. Cool. And that's that. So we're going to move on, and we're going to do age problems now. So age problems, same idea. We're just going to get a little bit more complicated, obviously. Out of these two, do whichever way, like you could have done way 1 for way 2, right? For example 11, like you could have used the same method that you used here for example 11. Some people find it easier, some people find the second way easier. It just depends on how your brain thinks and how you do math. And no way is better than the other one. Just to have different understandings of where you are with that current concept. Okay? All right. So we have example 12, which is a sum of Farron and Robert's age is 33 years. Robert is 7 years older than Farron. How old are the boys? Right? So we know that if you have Farron and Robert and it's 33 years, we know that. So let's say let F represent Farron's age. Let R represent Robert's age. Now, can we define Robert's age in terms of Farron's age? Robert is 7 years older than Farron, which means that R is equal to F plus 7. Right? Farron is 7 years younger than Robin, so you could have also written that F is equal to R minus 7. I would accept either one. Okay? How old are the boys? So you know that if you add Farron and you add Robin's age together, you get 33, because the sum of their ages is 33. Now I can just sub in for R, F plus 7. So I can just sub that in here. So I can say F plus 7 is equal to 33. F plus 7 is equal to 33. I'm going to collect these two terms, which is going to give me 2F plus 7 is equal to 33. I'm going to get rid of the 7 on that side, so I'm going to do plus 7 minus 7, so that they'll cancel out. Whatever I do on that side, I have to do on the other. So I have to subtract 7 from 33. So 33 minus 7 is equal to 26, equals 2F. Get rid of the 2, get rid of the 2. And that means that Farron is 13. That means R, F plus 7. R is equal to 13 plus 7. So you have 13 plus 7. So R is equal to 20. That means that Farron is 13 and Robert is 20. Therefore, Farron is 13 and Robert, oh my goodness, I can't write today. Robert is 7. And that's that. I will go over example 13 and 14 as well. I'll post them at the end of this lecture. I would go in and try 13 and 14 by yourself and see if you can do it, and then come back and watch the answers. Hi class, so I'm just going to quickly go over our example 13 and 14, and then we are finished. So I'm just going to finish up this lesson. So it says in 5 years, and these are more difficult questions. So these are the more challenging type questions. These are the type of questions that would obviously be worth more marks, and they're the type of questions you're going to see on your assignment. So just letting you know, these are the more challenging questions, especially 14. It's a little bit tricky. Okay, so we have example 13, and it says, in 5 years, Jonas will be twice as old as Rachel. Jonas right now is 8 years older than Rachel, right? So I'm going to say this, and Jonas at any moment is 8 years older than Rachel. So I'm just going to put this into terms that we can understand. So I'm going to say let R equal Rachel's age right now. And that's important. It has to equal Rachel's age today, right? Because that's what we're looking for. And let J equal Jonas's age today. Okay? And then what I'm going to do is I'm going to say, I'm just going to put stuff into terms. So I'm going to say Jonas is 8 years older than Rachel. So I'm going to put R in terms of J. So R is equal to Jonas, who is 8 years older. Jonas is 8 years older, so plus 8, plus Rachel's age. So Rachel's age plus 8 will give you Jonas's age. Okay? And then I'm going to go in and I'm going to say, so 5 years ago, so I'm going to say J minus 5, right? So that was Jonas's age 5 years ago. 5 years ago, Jonas, or 5 years from now, so Jonas plus 5. In 5 years, Jonas will be twice as old as Rachel. So that means when you take Jonas's age and you add 5, right, it'll be equal to 2 times Rachel's age at that in 5 years. Right? So Jonas's age in 5 years will be 2 times Rachel's age in 5 years, which is what I'm saying here. Right? Now I already have my j in terms of r, so I'm just going to substitute this value for j into this j. So I'm going to go r plus 8 plus 5 is equal to 2r plus 5. Now everything is in terms of r, so I can just go ahead and solve. I'm going to drop the brackets on the r plus 8. And then I'm going to distribute this 2 in. 2r plus 2 times 5 is 10. Right, I'm going to collect my like terms on this side. So 8 plus 5 is 13. 2r plus 10. I'm going to want to get the r by itself, so I'm going to bring this 2r over to the other side. So I'm going to subtract 2r here. I'm going to subtract 2r here. So I'm just going to bring this up here. So r minus 2r plus 13 is equal to 10, right? R minus 2r is just going to be minus r, minus 1r, plus 13 equals 10. Now I want to get that negative r by itself, so I'm going to get rid of the 13. So plus 13 minus 13 equals 10 minus 13, right? Negative r, the 13 and the 13 cancel out, is equal to 10 minus 13, which is just negative 3. You can't have a negative h, but you also can't have a negative r, so I'm just going to divide it by negative 1. And I'm given r is equal to 3. That means Rachel's age is 3 today, right? So if I want to find out how old Jonas is, I'm just going to say Jonas is equal to 3 plus 8, because r is equal to 11. So Jonas today is 11. Right? And if I wanted to check this, what I could do is I could say, okay, so I know that in 5 years, Jonas will be 11 plus 5, 16. And I know in 5 years, Rachel will be 3 plus 5, 8. And they're both, 16 is twice 8. So the equation is true. Okay? And that's how I always like to go back and check and make sure I did things right. Okay, this one's a little bit of a doozy, but we'll walk through it and it will make sense. Okay, so there's a few things going on here. The first one says 8 years ago, Susan was 3 more than twice Jasmine's age. That is, in itself, a very important sentence. Then it's going to say Jasmine is 10 years younger than Susan. Determine their ages today. I always like to start with the present because there's no time like the present. So let's start with the present. Jay is 10 years younger than Susan. So it's the same thing as saying Susan is Jay's age plus 10. Right? For the purposes of this lesson, I'm going to write my S like this because I start to get them mixed up a little bit. So I'm just going to write it like that. Okay? So that's going to be Susan. So I'm going to say let S represent Susan. Susan's age today. And remember when I said that today is really important, right? And let J represent Jasmine's age today. Now I'm going to go turn this sentence up here. So I'm going to maybe change this to a pink highlight and then I'll write the equation in pink as well. Okay, so I'm going to change that upper statement into something that we can work with. So I'm just going to change it. We'll go over to pink right here. Okay. Okay, so now I know that 8 years ago, Susan was 3 more than twice Jasmine's age. So Susan, 8 years ago, would be represented by S minus 8. Right? Before I do this, for me personally, what worked was I'm going to write Susan, 8, which means Susan 8 years ago, was 2 times Jasmine's age 8 years ago plus 3. Right? Because she was 3 more than twice Jasmine's age at that time. So it was 2 times Jasmine's age plus 3. Okay? So I'm just going to go back in and substitute my J8 and my S8. My S8 is just going to be Susan's age today minus 8. And then Jasmine's age today minus 8, right? Because this was all 8 years ago that it was happening. Now, this pink equation is the equation we're going to be working with, or working in. So you have S, again, I'm just going to make my S look a little bit nicer. S minus 8 is equal to 2 J minus 8 plus 3. I am just better off getting rid of this S over here and turning it into something with the J. So I'm going to plug in, I'm going to sub in my J plus 10 from here. I'm going to say, let's plug it in for the S. So I'm going to say J plus 10 minus 8 is equal to 2J minus 8 plus 3. And then I'm just going to solve. So J plus 10 minus 8 is equal to 2J, right? 2 times J minus 16 plus 3. Right, and I'm just going to collect my like terms. So I have 10 minus 8, which is going to be just positive 2, equals 2J. Negative 16 plus 3 is just negative 13. Right? And then, sorry, I'm just going to put my J in here. Now I'm going to move my J to the other side. So I'm going to have J plus 2. I'm going to move my 2J. So I'm going to have 2J minus 13 minus 2J because I'm trying to get rid of it. So it's going to come on this side. It's going to turn into J minus 2J plus 2. Right? Got rid of the 2J on that side. I'm going to just come in here and collect my like terms. J minus 2J is just negative J plus 2 is equal to negative 13. Right? Then I'm going to move my 2 to get rid of it. So I have negative J plus 2 minus 2 equals negative 13 minus 2. Get rid of this plus 2. I'm left with negative J is equal to negative 13 minus 2 is just negative 15. Can't have a negative H, but I also can't have a negative J. So I'm just going to divide both sides by negative 1. J is equal to negative 15 over negative 1 is just 15. That means Jasmine today, which is what my J represents, right? J represents Jasmine's age today. Therefore, Jasmine today is 15 years old. I want to know how old Suzanne today is. So Suzanne today is just 10 years older than Jasmine, which means Susan. Susan today is 25, right? Because S is equal to J plus 10 is equal to 15 plus 10 equals 25. If I wanted to check this, I could. So I'm going to do that in orange, right? So 25 minus 8 is equal to 17. Jasmine, 8 years ago, would have been 15 minus 7, right? Which is going to give me 14. 8. So Susan was 17, which was 8 times 2. I did something wrong here, guys. Sorry, I apologize. So we did 15 minus 8. This was 8 years ago. So 15 minus 8 would be 7, right? So 7 multiplied by 2 is equal to 14 plus 3 gives us 17, right? Because we know that Susan, 8 years ago, was 2 times Jasmine's age time plus 3. 2 times Jasmine's age plus 3, so 7 times 2 plus 3. And that's how I would check. You just got to make sure you get their age 8 years ago first. Okay? And I hope that makes sense. This one was actually really hard. Even I found it hard. So just be careful because sometimes the wording is what gets people. So just make sure you read the question carefully. Okay? And those are the 2 questions that were left. Hopefully this has been a helpful video. I'm sorry it was so choppy. It's just I've been having some technical issues, so I had to make a few videos to make this one work. Okay, see you tomorrow.